An electric motor can feel like a total black box, right? But what if you could map its entire performance in just one picture?
Yeah, that was the big challenge for engineers. How do you predict everything without endless tests?
So let's check out the really elegant tool they came up with for this. And here it is, the circle diagram. It's basically a complete performance map for the motor. So how do you actually make one of these maps? Turns out you only need a couple of tests.
First, you plot the current with zero load, then with the rotor locked. Boom! Those 2 points define your circle.
Okay, let's see how this works in the real world with a 5 horsepower motor. After running the tests, we get a circle. Its diameter shows a max current of 82.5 amps. And this is where it gets really cool. Simple lines on this map tell us everything. Things like efficiency, power factor, torque. It's all there just by measuring lines on the diagram. So you can just pick any point, say when this bigger motor is drawing 80 amps. And just from the geometry, we know its efficiency is almost 91%, pumping out over 73 horsepower. But this map does more. It actually tells us a lot about the motor's basic design. So check this out. We've got 5 different motors, from slow 60-pole ones to fast 4-pole models. And you can see the pattern right away. More poles means lower speed and a way smaller circle. And that directly hits performance. The low-speed motors have a smaller operating range and a worse power factor. Okay, but why? Why does having more poles mess with the power factor? Well, it comes down to magnetizing current. Motors with lots of poles just need way more of it. And here's the kicker. That extra current does zero useful work. It just tanks the motor's efficiency. So after all this, you might wonder why this old-school diagram is still so important. Because it visualizes the entire performance of a complex machine from just 2 simple data points. It just goes to show you, sometimes the most elegant picture tells you more than pages of equations ever could.